Good evening, welcome to my laboratory. What you're looking at here is the Little Bryan demonstration board. There's the Q2 MOSFET, this is the Q1 MOSFET. It's wired exactly as the diagram shows, except I'm using a 1 ohm 5 watt current viewing resistor right there. 1 ohm 5 watts, okay, and it's not warm. Here I have two 5 ohm resistors in series. These are 10 watt power resistors, I believe. I've covered them up with tape, but they're the same ones I was using before. And I have the thermocouple from the Fluke thermometer wrapped up in there, and it's recovering from a heat pulse right now. It's 34 degrees Celsius and it's about 20 degrees Celsius ambient. I've got 3 batteries in series, 1, 2, 3, 12 volt batteries. This is the inline current monitor, and I have the function generator hooked up as the Ainslie schematic shows. We're monitoring across the current viewing resistor for the current trace, and we're monitoring the function generator's output or the gate drive signal right there. The Q2 MOSFET source and the Q1 MOSFET gate go only to this function generator and scope probe there, just like in the Ainslie drawing. Okay, so now we've got the standard setup with the F43, 1.5 kilohertz and a square wave signal. See if the scope is warmed up. Yeah, okay, so the baselines are there. Alright, and we're looking at the current viewing resistor at 2 volts per division, and that is with a 10x attenuated probe, and the other one is at 5 volts. The gate drive is at 5 volts per division with no attenuation. So I'm going to bring up the amplitude on the... first let's just put in that little bit of negative offset. Oh, that was too much already. So we want to put in just a little bit of negative offset, and then turn the amplitude up until we get the oscillations in the Q2. And then if I go over 4 volts on the amplitude with the square wave there, right about there, I start seeing a lift in the Q1 trace. You see that? So there's, can you see the gradical all right? Let me turn up the gradical. That's about as bright as I can get the gradical there. But I think you can see that as soon as I hit 4 volts positive, right about there, the gate lifts up, or rather the current through the Q1 MOSFET starts showing right there, right? And of course I get more oscillations, and I can actually drive the Q1 into oscillation too with my function generator. Ainslie may not be able to do this, but the F43 can. Okay, but anyway, what I want to do now is show what happens when we go to a different waveform. Okay, so first what I'm going to do is just go ahead and select the triangle ramp waveform here. Alright, and using the variable symmetry control, I can control the tilt of this now sawtooth waveform. That's the regular triangle ramp there, but I want to tilt it over to the left, like this. Okay. Now, when I raise the amplitude, we start seeing what I call turnips. Okay. And if I play with the offset a little bit, I start seeing things that look very much like the scopeshot's SCRN0183 and 184, right? There's some Q1 turning on there. Okay. And so now what I want to do is go up to the frequency that's shown in those other scope shots. So here what we'll do is we'll go ahead and change the frequency to about 30 kilohertz. Okay, and then we'll change the scope's horizontal time base to 10 microseconds per division, and we'll raise up that gate drive signal again. Okay, like that. And to my eye, this looks very, very much like one of Ainslie's screenshots. All right. So 183 or 184. One of those. Okay. And let's see what that looks like at 50 microseconds per division. And this looks like very much like the other one, the SCRN0184 or something like that. And now if I simply change the scope's time base to 500 microseconds per division, we have Ainslie's figure 8. Paper 1. Alright, and that's this basic kind of waveform there, something on that order. Now, if I turn everything down and I check the reading on the thermometer, you can see that all of that actually did raise up the temperature of this little load by quite a bit, that heat pulse. But this 1 ohm current viewing resistor here is still absolutely cold. Okay. And that's where the heat's coming from, is this Q1 on time that sneaks past when you have the offset set like that. Alright, thanks for watching.